You're listening to Weird and Dead, the paleontology podcast that tells evolution's most embarrassing and bizarre stories. I'm Megan Wetherell.
I'm Amy Atwater, and we are two living scientists who are weirdly excited about dead things.
On this episode, we talk about all things trace fossils, from poop to butt prints to unexpected foreskins.
Yeah, of course, duh. Why wouldn't we? We also discuss the finer points of vomit fossils, which, yeah, that's a real thing. Bet you didn't know that. And reveal the beautiful mystery unraveled by our hero and yours too, paleontologist Mary Anning.
Like always, our podcast talks about some disgusting things, so definitely don't eat while listening to this episode, and check the warnings in the description.
All right, today is a fun adventure. Also, I'm just excited. We get to talk a little bit about our girl Mary Anning, who you are going to hear about a fair amount on this podcast. In fact, that's our original blog is Mary Anning's Revenge. So we are going to be talking a little bit about fun other types of fossils today. You know, body fossils get all the attention, right? Like his big dinosaur bone and mostly just bones. But there are a lot of other type of fossils out there. And a really fascinating type of fossil are these trace fossils. There's a story that you and I like to talk about a lot about a unique type of trace fossil and how it was discovered. And it goes back, it's really cool because it kind of interacts with like cultural history too, and the use of bezoar stones. And so these bezoar stones are these small rounded shiny stones. They were really spherical. They were prized because back in the day, like hundreds of years ago, people thought that they could cure literally anything. Like they thought it could cure a sore throat. They thought it would help a toothache. They literally thought it could cure leprosy. And also neutralize poison, which then someone tested that. It did not go well. It's just a bummer. So most bezoar stones are actually, I mean, this is also gross. They're found in like the guts of animals. Like they are built up masses of undigested like hair and inorganic material. So they're essentially like stomach stones, and they would use these for everything. But then there are also like other types of bezoar stones that were more like classic, maybe actually like simple small stones. And a lot of these types were found along the beaches in southern England back in like the 17th and 1800s. And that's actually where Mary Anning is from, our girl. So Mary Anning, she was born and raised in Lyme Regis in 1799. She was a famous paleontologist who really didn't get much credit during her day, even though she made phenomenal discoveries from literally the age of a small child. I have said literally a lot already in this episode. Literally. Anyway, she and her family supported themselves by looking for fossils to sell to tourists because it was this southern English town where people would come to heal from their tuberculosis and put bezoars in all of their, they would put these stones in their tea and like drink, you know, and it's like, I'm going to be cured. And she would find these bezoar stones a lot when she was out looking for fossils. And she would find them pretty frequently. Like, so she's famous for finding, her and her brother, the first complete ichthyosaur, which is like a fish lizard thing from like, you know, the Triassic and Jurassic. I think they look like pregnant dolphins, but they are not. They are reptiles. They're marine reptiles. They're not dinosaurs either.
They're just sneaky pregnant dolphins. That's what they are.
It's just convergence, everybody. Everyone wants to look like a big pregnant dolphin. I know I do right now.
Oh no, I just laughed like a dolphin.
Oh man, I'm so sorry.
Oh no.
So she also found the first complete plesiosaur, which is like this long neck sea monster looking motherfucker who also is called a dinosaur all the time, and it's not. It's another marine reptile. And so it's really interesting because she would find these bezoar stones, these like small rounded stones, kind of in like the guts or like the pelvis region of these ichthyosaur fossils that she was finding. And she was really, really curious about them. And she was like, I don't know if I think these are just like simple rocks. I think they might be poop. And so our brilliant queen decided to like break them open and found like little bones, crushed up smaller bones in these. And it turns out that she was totally right. Like these were fossil poop from ichthyosaurs, and people were using these fossil poops and putting them in their tea and literally drinking shit. I mean, fully fossilized, guys. Like no organic materials probably still remaining.
If you're gonna drink shit, you should drink fossilized shit. But I also wouldn't advocate for either.
It is just, it's very funny. And so her discovery was some of the first time, I think it was the first time that anyone had really documented the presence of fossil feces. And this, you know, a white guy, of course, had to publish on it and name it because Mary couldn't. It's William Buckland is the one who actually, because of Mary Anning's work, coined the term coprolite, which really does translate to fossil poop, fossil feces. And it was because of our girl and her brilliant mind. Even though she had zero formal education, she was a freaking genius. And we will definitely talk more about her later on. But yeah, Mary Anning figured out that all the people of Lyme Regis and probably across the world were putting fossil poop in their tea and on their bodies and being like, I'm cured. So it's just a beautiful example of the intersection of paleontology and culture, and a fun little anecdote to get us started today as we talk about trace fossils, as fossil poop is a classic type of trace fossils. It's not the animal itself. It is a remnant. Yeah. It is a sign of life, but not actually the body itself. So trace fossils, poop. It's all, we're going to talk a lot about poop today.
So we are going to talk about trace fossils this episode. So a fossil itself has a really loose definition. It's anything that's older than 10,000 years. And a trace fossil is any ancient or any sign of ancient life. That's a lot. There's a lot of different types. So we're going to talk about the basic big groupings of trace fossils. But when people think about trace fossils, the ones that typically come to mind are tracks and burrows. And tracks and burrows and poop, all of these things can tell you a great deal about the animal that made them, if you can discover which animal made them. But they can also tell you like incredible ecological stories, and they can give you a ton of information about animal behavior that you really can't get from bone fossils, for example.
It's true. I mean, I was just talking about this. I remember when I first heard about trace fossils being used to interpret behavior, and of course, my brain immediately went to like, what? So you can tell like the personalities and attitudes of different fossil life. Like, man, Daspletosaurus was a real bitch. But like, it is like, that's not necessarily what we're talking about when we say behavior. Yeah. It's like, man, this one was really moody. It's more basic life behaviors than that. It's like, how did you walk? How did you sleep? How did you stand? How did you poop?
I would say you could probably tell if a dinosaur had like hot girl stomach, because you could see how many poops were backed up inside of it. But most behavior, we're talking about like generalized life behaviors, not specific human interpretable behaviors. Let's talk about tracks.
Yeah, that's probably one of the most well-known types of trace fossils, and it probably gets like a lot of attention. Are tracks, like signs of an organism moving through some sort of substrate or leaving a track or a trace again on some sort of substrate. So I worked for a park where I got to study dinosaur tracks. After my undergraduate, I went to Denali National Park and Preserve in Alaska. But Denali, it was very cool. It's very neat because the rocks that have the dinosaur tracks in them are often exposed after landslides. So you can use geomorphology and use a lot of like those tools to be able to find your track sites or understand like where the tracks are going to be. And that was my job. I was a GIS person there. I built a software to be able to essentially predict where more dinosaur tracks were in the park because it was so expensive to do field work in the park. we didn't have a ton to be able, like most of them were in the float. So they weren't like in bedrock themselves. They were just like eroded chunks of rock that had individual tracks. So that makes it harder to interpret behavior, right? Because we didn't have a trackway necessarily, though there was one section that was a huge trackway. I never got to go to it because it was literally that deep in the park. So again, that can be really, really useful. Trackways are not just like a dinosaur thing. I mean, obviously we see organisms like way before the dinosaurs are leaving trackways and whatnot. And also humans have some fascinating trackways as well. The Laetoli tracks in Africa are famous for being Australopithecus trackways, and some of our earliest signs that early humans were already bipedal by, 3.5 or so million years ago, or at least mostly bipedal. Don't quote me on those ages. I'm pulling that out of my grad school brain, and you can tell I'm not on fire today with that. But the really, really, really cool human tracks I wanted to talk about are in North America, because North America is the best. And this is really kind of more going into archaeological territory too. So, deal with it, y'all. But, there's been a long debate about when humans got to North America, right? Like prior to this, actually, Oregon, some coprolites, some fossil poop from Oregon, we might hear more about later, was interpreted to be some of the oldest signs of human inhabitants in North America. And they're like, what, 13.4 or something like that million years old?
Yeah.
Not million.
14.
Oh my God, Amy.
Thousand years.
Humans have not been in North America for 13 million years. Oh. Oh my gosh. Anyway, it's been, hotly debated, and a really cool discovery that's come out in the last couple of years is from White Sands National Park, which is in New Mexico. It's outside of a little town called Alamogordo. And they have found these are gypsum sand dunes too, which is really, really cool. So it's like an evaporite instead of like a classic sand. Silica, I guess, would be the opposite. And so they don't last very long, but they were able to find human trackways and other ice age animals like sloths. I think it's the Harlan's ground sloth, I'm pretty sure, that they've also found as well. And that they may have even been tracking the sloth to hunt it and whatnot. And they were able to kind of essentially dig trenches in the park to look at different layers and different tracks within those layers that were also embedded with some really great like plant material that they were able to date, radiocarbon date, to get an age of like around 23,000, maybe a little bit younger, maybe 22,000 years, pushing back our date for humans being in North America by like almost like 10,000 years. Is that math right? Oh my God. 23 minus 10 is 13. Okay. And I think these tracks are really, really cool, not only because they're beautifully preserved, not only because they change our entire picture of when humans inhabited North America, but because I'm very emotional these days. One of the sets of tracks appears to be a toddler and probably some sort of parent. They're, of course, interpreting it to be a mom. And sometimes the toddler tracks disappear and the mom tracks are actually deeper, and it's interpreted that the kid was being picked up and carried off and on during this journey too. So again, like behavior, like we would not be able to know that. Well, I'm sure every parent out there is like, no shit, you picked up your kid. They're annoying. Like, I don't think it was any different 22,000 years ago, but it's very cool to be able to use trace fossils to like truly interpret that. And there's some other cool track sites too. We've talked enough, but there's some cool ones to be explored in North America if you're interested, and all over. They're fascinating. So, those are some of my track experiences, though I haven't seen the ones at White Sands yet, or probably ever.
Yeah, trace fossils and trackways in particular are surprisingly common when you think about how like precise the environment must be for these things to be preserved, because it has to be sediment that is appropriately like wet or loose for you to sink into. And that it has to be not so wet or so loose that when something else covers it up to preserve it, that those things disappear. So the fact that we have trackways going all the way back to like the Ediacaran is kind of nuts.
What?
And some of those trackways are not the trackways of feet. Some of them are things like tail drag, and some of them are little teeth, little tooth marks, or feeding traces. So one of my favorite trackways is not technically a track, it's a feeding trace, and it's called Kimber Ichnis. And it looks like these little like funny scratch marks. If you've ever seen a snail travel across like the surface of an algae-filled aquarium, they look very similar. It's just that Kimber Ichnis, they made these weird fan shapes because they think that the organism who was making them was backing up as it was like taking chunks of algae off of what at that time was a really hard surface. So not only does Kimber Ichnis tell us a little bit about how this particular animal was eating, it also tells us a lot about the ecology of the world, because if you look at seafloors now, you don't see hard panel bottoms with algae growing on them. You don't see like a glass aquarium. We see soft sediment, which is very different from what existed in the Ediacaran. Kimber Ichnis is also one of the few trace fossils where we actually have a pretty good idea of who made it. Trace fossils are kind of hard to figure out exactly who made them. Like,
yes,
if you don't have a foot that is trapped inside the trackway, it's not a guarantee that the thing that you think made it actually was correct. With Kimber Ichnis, it was named Kimber Ichnis because they thought it was probably made by Kimberella, which was an early mollusk. So like it looks like a slug pancake is kind of all of the reconstructions. The reason that we're now pretty confident that yes, in fact, Kimber Ichnis is made by Kimberella is because we have found dead Kimberella. So your last meal, your last supper is preserved. Also, I do sell clothing with Kimber Ichnis patterns on them.
And it's very cool.
Very cute. They're very pretty. You could be carrying hickeys from the Ediacaran if you really wanted to. I mean, they're kind of hickeys. They're definitely not smooches.
That's freaking cool. Yeah. Mm-hmm. It's a great print. So check it. Check it out.
Yeah. So feeding traces are common. We see kind of these weird erratic feeding traces in the Precambrian, where we have organisms that were big enough to leave trackways, but that didn't really have like eyeballs or maybe chemosensory organs. So they couldn't actually tell what they were looking for. They were just blundering around in a world. So they leave like all of these strange kind of erratic shapes as they went about their day. But of course, it's not just trackways and feeding ways. There's also things like burrows. There's a couple of very famous burrows that are preserved out there. I think my personal favorite, and probably Amy, this is one of your favorites too, is the Devil's Corkscrew or the Demon Helix. Yeah. So did you get to see any of those when you?
Yes. Yes.
Jealous.
Yeah. So, that's true. I was going to mention, I am one of the few people in the world who was like, I want to go on vacation. I'm going to go to Nebraska and South Dakota. But my friend Katie and I did a fun fossil trip. I hadn't been to South Dakota or Nebraska or like Badlands National Park. And we went to some sites in Nebraska, including Toadstool Geologic Park, which is really, really cool. There's an entelodont trackway there of entelodonts, which are like these hell pigs chasing down rhinos, which I don't know. I think like the reverse, right? Like I want to run from a rhino, but this rhino is scared of this giant, terrifying pig thing. And then we also went to agate fossil beds as well. It's, I think, a national monument. It's kind of out in the middle of nowhere, but you could hike around and see the actual Devil's Corkscrew still in the rock. The plexi that was preserving it looked pretty busted, but you could still get like a pretty good view of these. I mean, they're huge. They're like as tall as me. You know, they're quite large in size, and it's like these almost perfect corkscrew shapes in the rock, which I mean must have just been so trippy to discover those. And be like, what is this?
Yeah, you know what they first thought they were?
No.
Algae. They thought they were weird algae. There were some people who were thinking they were tree roots. Some people thought they were algae. But it took a pretty long time for people to demonstrate that these were burrowing beavers, which really, when you say that, of course it took a long time. Did they even know that the beavers burrowed?
Seriously.
But Demon Helix, so it's this big corkscrew, and then at the bottom, it like juts off and up like a hockey stick. So if you find a really well-preserved one, you'll find it like that. And there are some that are so well-preserved that the teeth marks of the beavers are preserved. So if you look up close at these burrows, you can see little scratch marks from beaver teeth as they carved out their burrow.
Wow.
But of course, there are also beavers found in the bottoms of these burrows.
Helps.
And that helps.
That helps.
It's not a guarantee. Just because you're in a burrow doesn't mean that you made it. And just because you're in a burrow doesn't mean you went there voluntarily. Sometimes you get eaten.
Yes. Or washed into.
Yeah. With this, there were a fair number of beavers in the burrows, and their teeth were preserved. They think that they built these long corkscrew burrows as a form of temperature control. As a person who lives in a very windy area, I do understand that you can't just make one turn and expect the wind to not form an eddy and come back around. So that's part of why they had multiple twists and turns, is to ensure, because it was a very windy area. There's a lot of sand dunes. And a lot of big sandstorms probably that they were trying to avoid in the summer. So you have to have multiple corkscrews in order to get that air conditioning system where essentially you're lower in the ground so you're cooler and there's not sand just blowing in your face.
Wow. Oh man, wow, it's fascinating. And then, yeah, I guess I was thinking about burrows too. Like there have been some Eryctodromius is a dinosaur in Montana and Idaho that's been interpreted to be a burrowing dinosaur, and part of that has been because they have found them in like burrow-like structures. And while I think that's like really fascinating and probably the case, I always had this question in my mind of like, what if you got washed into that burrow? What if it wasn't your burrow, but your bones ended up in it just because of taphonomy and like a big flood or something like that? I don't know. It's just it obviously helps when the organism itself is in the burrow, but it's not. I still have questions.
And then there's still a lot of examples in modern ecosystems, like so pocket gopher burrows. Okay. Have you seen the like traces of like big tubes of sediment up in like the mountain when the snow melts?
Yes. Freya used to just go ape shit for those things. Yes.
Jellybean loves those things. So they're called eskers, by the way, which is like a glacial feature name as well. Pocket gophers are pretty well known for making these extensive burrow systems. And then when the pocket gopher leaves or dies, they get taken over by other rodents. You find snakes moving in pretty much immediately. And easily those animals could be preserved in the burrow, and you wouldn't necessarily know that it wasn't their burrow.
Yeah.
So yeah, trace fossils, you don't always know the trace maker, which is often why they have really weird names that are not related to the trace maker, because they could have been made by something else and they don't know what they are.
Those are interesting.
All right, I think we're gonna take a quick break, and when we come back, we're gonna talk about something that's even better than stupid corkscrew burrows. We're gonna talk about basically what everybody's like in the mid-90s was like a chief prank, like where you went and you took your butt scan on the scanner.
Oh, yeah.
That's a fossil now. There's fossils of these. So when we come back, we're going to talk about butt imprint fossils. Looking for more great science content? Check out All Things Biology, a short-form podcast focused on, you guessed it, biology. I enjoyed the Are Vitamins Good For You episode and will be passive-aggressively forwarding it to my vitamin-pushing mother for sure. You can check them out on Spotify and Apple Podcasts.
Enjoying this episode? Help us make more of them by supporting us on Patreon. For just the cost of a fake trilobite a month, you can enjoy tons of bonus content, outtakes, clips we couldn't fit, and of course, suggest episodes for us to film next.
And now we have returned, and we are going to talk about butt imprints. So butt imprints fall into a group of trace fossils. Their formal name is probably Cubicnia, which is resting traces. So some things rest on their butts, some things rest on their tum-tums, but resting traces is what we're going to talk about next. So resting trace fossils, I think universally are the cutest trace fossils. Amy, would you disagree?
I think that they are the most embarrassing in some cases too.
Yes.
Like these are the things that you probably wouldn't want preserved for millennia. You know, like this is how my weird body rested on this weird sediment. Or like I'll get to it, but some of them are, I think, capture accident moments too. And so then it's like, I think that's pretty funny. So
little slipperoo.
Yes.
So one of my favorite resting traces is a resting trace. It's called Hermindicnus. So you may have heard of the animal Diplocaulus, but for those of you who have not, it was a big amphibian-like thing. Looks like a giant salamander from the Permian, I believe. Mm-hmm. And it had a giant, like, boomerang-shaped skull. And so for centuries, people have kind of wondered what the hell it looked like. And I would say it's also now in Ark survival. So if you look up Diplocaulus, that's what's going to come up first. The Ark survival is not accurate because it does not take into account Hermindicnus. So Hermindicnus is a resting trace of probably Diplocaulus or a close relative. It has the same general shape, big fat boomerang head, and it's around the right size. But what Hermindicnus has that is really funny to me is that shows that between the boomerang-shaped head and the big salamander-shaped body was this big, loose roll of skin, like a foreskin for its face. So, Diplocaulus probably had jowls that connected from its cheeks to its shoulder blades, as according to Hermindicnus. Either that or that one was just really, really wrinkly. Cubicnia can give you kind of important like pieces of information about physical structure of the animal, as well as things like behavior. Mm-hmm. So another one of my favorites is a resting trace called Rusificus. And I'm going to send a picture really quickly to Amy.
I'm excited.
I'm going to send two. And Amy is going to describe them to you. Okay, so here's the first one.
It is like this long organism, maybe your trace. It kind of looks like a snake in some ways. It's kind of got that sinewy vibe to it, but you're kind of almost braided like rope. And then at the left side of the screen is more of like a bulbous portion that if I were to just like look at this, I'd be like, it's its little face. Then maybe it even has some fibrous-y kind of, I don't know, feathery structures coming off of the longer part of it too, which gives me like centipede or millipede vibes, which I actually don't like. So
yeah. Okay, so it's the one that I just sent you is technically two trace fossils.
Oh.
It's Rusificus and a trace fossil called Cruziana, which is the walking traces of trilobites. So Rusificus is that lumpy bit at the bottom left. Now I want you to look at this one, which is just Rusificus.
Okay.
And as she looks at this, I want everyone to keep in mind that when you're talking about like a footprint or a resting trace, there's two halves. There's the imprint that you make, and then there's the sediment that fills in and often makes a cast. So the casts can often be a little bit harder to interpret because it looks like a big lump.
This is lumpy for sure. And I can see kind of like two parts of the lump that are in parallel to each other. And they look almost like a big pair of juicy lips.
Yeah, don't they? Oh, you're thinking upper lips. I was thinking looked like lower lips.
My first thought was definitely lower lips, but I was trying to not be me.
Yeah.
So I went with lips. But
it was, like I said, the perfect trap that you avoided.
But lips is vague enough to cover both territories.
They look like lips, whether you're thinking of upper or lower. And what they actually are is a resting trace of a trilobite.
Wow.
So my favorite thing about this resting trace is that sometimes you find them at the end of that Cruziana, and they basically like buried themselves down a little bit. Rusificus is when a trilobite buries itself in the sediment, which could happen either during them trying to eat something, so predation when they're eating something, so snack time, or it could be as a defense while they're sleeping. So it's snack time or nap time. That's what Rusificus is.
Aww. Or lip time. They look like they've just been a lot of
like
all my favorite drag queens with their big Lips.
All right. Speaking of lips, let's talk about butt prints.
I love any embarrassing stories about dinosaurs. It brings me great joy.
Yes.
And so one of the funny things, Jim Kirkland is a really amazing paleontologist. He's the state paleontologist for Utah. And I think I was listening to his Paleo Nerds episode. I think that's where I heard this, where he was talking about this dinosaur trace fossil from Utah, from St. George. And so there is this track site in St. George. It's really pretty cool. I think it's about, approximately 200 million years old. And it has a lot of really cool dinosaur tracks. And what's really neat is that it was clearly not necessarily like fully aqueous, like not all water. It's like interpreted to be a lake site. So we're talking about like kind of shoreline activities. Again, looking for that perfect mixture of both soft enough to take a track, but not so soft it's getting erased. And what's really cool is like, because it's like this shallow lake environment, they have areas where their toes and claws were just kind of like scraping along the surface, like maybe some light swimming, maybe a little dog paddle, something of that. But they also have a site where they actually have a spot where a dinosaur has like sat down, like crouched down and sat in the mud, and it left behind like a handprint, a footprint, a tail print, and then the ischium, which is, I always remember the ischium by the ischium is on your bum. And that is for us. So like when you are like us sitting down right now, our ischium is what's making, we have two of them though, of course, contact with our chairs the most. It's that the ischial spines. And so it's very clear that this dinosaur just like took was resting, was just hanging out, and just like left this perfect butt print. So, I think again, that's just really funny to me to think that your record that you're leaving behind for 200 million years is an impression of your butthole. But, here we are. And it's, there's also another spot preserved where it looks like a dinosaur like slipped in the mud and like ate shit a little bit. It's like, and that's what I was talking about earlier. I just feel like a lot of times, like, trackways or resting traces can preserve some embarrassing moments too, because it's, we've all done that. We've all made that stumble and then look around to see if anyone noticed. And it's like, well, it didn't matter if any other dinosaurs saw it, because now all of humankind can see you slipping up in the mud just 200 million years after you've been around. And so it's a very cool site. This is the St. George dinosaur track site, I believe. I haven't been there yet, but I'm really hoping to go someday to see a butt print in person. I just think that's so great. Yes. But, butts are not the only thing that gets preserved thanks to trace fossils. And I was going to also say with your Diplocaulus neck foreskin is that it's not just structure. It's not just behavior. It's a lot of times, and we've talked about this before, it's soft tissue that we actually can get an idea of what the soft tissue and therefore the actual entire organism, or at least more of the organism's anatomy than would have been previously available to us with just bones alone. And butt prints help us with that too. We can understand that, these dinosaurs had those big old booties. They probably didn't at all, but it's fun to think
I thought
about.
you were going to make this transition. It's not just butt prints and things that come out of butts.
That's
or
true.
Don't come out the other direction. Also,
well, there you go. You did it for me. We're talking about the things that are extruded out of animals' bodies and left behind too.
Yes.
We were talking about Mary Anning at the beginning of all this and ichthyosaur poop, and she was able to figure it out because of the context of finding it always in the pelvic region of these skeletons, and then also breaking them open and seeing that there was like bony hash inside of them. So figuring out if it is a coprolite or not, so fossilized species or not, sometimes there's really obvious signs about it. Like I have worked with some crocodile coprolites that are like a little bit spiraled, and then one end is like squeezed, and you can actually see like sphincter marks like on the butt. I will post a video of it. I have a video of it. It's hilarious. While then
she has a video of the fossil, not a video of a sphincter picture of a crocodile.
I can get that too.
That's true. That's probably available on the internet.
I know croc people. I could make the. I don't want to do that. I didn't want to do that. But some coprolites are really hard to determine too. So I've been to the like Egg Mountain site up in Montana, which is famous for Maiasaura and the good mother lizard and all that stuff, which we, you'll have heard or will hear about. And those are hadrosaurs. So we're not talking. You can't find bones necessarily, though they did eat a little bit of invertebrates here and there. It is apparent. So you can't look for like bones like you could with the ichthyosaurs. And the coprolites up there, they kind of look like a conglomerate. Like there's just like a rock that you can see lots of different types of littler rocks kind of within it. And I would have had no idea that they were coprolites until someone told me they were. And they've been studied by Karen Chin, who is one of my heroes. She is the dinosaur poop queen. She does incredible research, and she's identified this material as dinosaur coprolites through a variety of techniques and analyses, but they don't look like turds. Like they don't look like poop. So it really depends. It really depends on what that, but so that's out the back end, but I think we have stuff that comes out other parts of us too.
Woohoo! Just a full circumference podcast. You think it's difficult to identify something that came out the back end of an animal as a coprolite? I want you to imagine that it didn't get that far. So vomitites, for example, there are examples of fossil vomitites, so a vomit fossil. My favorite is at Ashfall Fossil Beds. I got to take a selfie with it, and it's the best selfie I have ever taken in my entire life. And it doesn't really look like much. It's just a bunch of like bone shards in kind of like a flat plane with a slight textural difference to the matrix compared to the rest of it. And the reason that they determined that it was a vomitite and not just diarrhea was they took a look at the actual bones themselves. And if bones go all the way through a digestive tract, they have a ton of acid etchings.
Yes.
Acid can remove things like it can remove enamel. It can leave big holes in your fossil. Yep. So the longer that your fossil is in a stomach of an organism, the more acid etching it's going to have. And these ones had very, very little acid etching. So they went in and came right back out. And so when I was looking for other examples of vomitites beyond Asheville fossil beds, that the vomitites there are the final layer of fossils basically up on the top, because you had this big volcanic event that killed a bunch of smaller animals immediately and then slowly killed a whole bunch of rhinos over the course of weeks. It gave them horrible, horrible bone diseases. They were running fevers. Just too much ash. You can't live like that.
Nope.
So they died. They got buried a little bit. And then things like bears and dogs came through, could smell the carcasses and dug up some of them and ate them. And those carcasses had been rotting for a while. So there was vomitite.
This is great.
Yeah.
This is
yes.
disgusting.
But oh my God, the amazing taphotomy of that site. Oh,
right.
Blows me away that you could tell that whole story, even as gross as that story is. But vomitites they can't always be very easily identified. And as I was looking for vomitites, I found a paper which introduces a whole bunch of new lingo into the conversation. So I'm going to pull it over and I'm going to read some of it to you guys because I didn't memorize it. I'm sorry.
There's so many different words for puke, fossil puke, though. Which, I mean, that's fitting. Like, we have so many words, colloquial terms, also to cover the gamut. So let's do it.
This whole paper is about bromelites. So a bromelite is anything that like went into an animal, whether it stayed there, came back up one end or the other. It's called a bromelite. That's the big general term. And then they go on to define new words like regurgitites, where you puke it back up. A metatite, which is like a pellet, like an owl pellet.
Oh.
They've got, let's see what else. They have digestolite, so something that got into the digestive tract and then is just preserved there. Pabulites are fossil food that never entered the digestive tract, so something that got stuck in their craw before they died. And they initially, as I was reading through this, I have to admit I was rolling my eyes pretty big, because I've seen a lot of papers like this where they just want to make the most complicated terminology for things when you really don't need that terminology. But then I kind of left that paper on the side, and then I went and started looking for vomitites again, and I couldn't find them. So I started Googling emetites, and I found a whole bunch of pellets, but I couldn't find any vomit. So then I went and looked at regurgitites, and some of the papers that I hadn't seen before came up. And I realized that even though this is a lot of terminology, I think they introduced like 10 or 15 specific terms, those actually are kind of important because you don't want to just Google fossil pellet because that could mean a lot of different things. And it's not an owl pellet, it's a dinosaur pellet.
Oh, interesting.
And the reason I couldn't find vomitites is because not everybody called them vomitites. There's a lot of different terminology that people were using. And that's also depending on whether it was going in and then coming back out. If it was coming out on purpose, like a pellet, if it was coming out by accident, then it's a regurgitite. So yeah, I rescind my initial hesitation with this paper. We do need to be a little bit more precise in our language because it is very difficult to Google fossil vomit.
I can only imagine why.
Right?
That's really interesting. Also so I study or have studied, I don't know how I feel about it, very early primates, right? Like the really cute little ones. And one of the best ways that we have to find them, or at least have in the past, have been interpreted to be like owl pellet sites.
Yeah.
And that they have already done the work of finding the cute little thing that they ate and concentrating them. And so it's much easier because otherwise primates are such a small part of the ecosystem. It's very hard. They're very rare to find. But when you find them in a higher concentration, it's probably because something was eating them and then doing their pellet system thing. So I hadn't thought about that technically being a trace fossil that preserved within body fossils of my little itty bitty cutie patooties. So thank you, owls, for vomiting up your food. Thank you. I appreciate it so much. So,
and there are example of dinosaur pellets as well. So,
wow,
yes,
I didn't know that.
Dinosaurs,
I know.
blah, blah.
Non-avian, we get it. All right, avian versus
so
non-avian.
there is, from the Upper Triassic of Italy, there is a gastric pellet, an emetitite, that they thought had a pterosaur in it.
Oh.
But have since gone back and look at it, and I guess it's not actually a pterosaur. It's something that's kind of like a pterosaur, but not quite. But yeah, it's basically the equivalent of an owl pellet from something that was much bigger than an owl.
Wow.
Which is cool.
And terrifying. That's also like terrifying as a prey. Also terrifying if you were ever to witness that.
So if you're not familiar, by the way, with owl pellets or why owl pellets happen and why we're calling them specifically owl pellets and not eagle pellets, for example, any bird of prey that eats animals whole, they have a choice with what they do with that bone. Bone and fur are really difficult to digest. They don't have high nutritional quality. So you can either choose to have an extremely acidic stomach that will digest that sort of stuff, which is, I think, what hyenas largely do. They have a very acidic stomach, so they don't cough up pellets even though they swallow bone chunks. Or you can choose to squeeze out all the nutritional goodness and then puke up like a wad of hair and bone. And owls have gone with the wad of hair and bone. They have much lower acidity in their stomachs than things like eagles and hawks do.
Okay.
So eagles and hawks do technically make pellets sometimes, but they're very small and they're harder to tell because a lot of times it doesn't have hair in them. It's mostly bones. So yeah.
Wow.
Owls, we think of them as being like the primary pellet former because they're way more likely to make a pellet and there's more stuff in their pellet, whereas other birds of prey choose to just mostly digest that stuff.
Right. And then you have to expend some energy to be able. That's interesting. I hadn't thought about that before. Like why it's always owl pellets. So I learned something today.
No good.
Yes. I mean, okay. So we've also, we're talking about puke and everything. I mean, so if we're talking about digestive system stuff, another like critical trace fossil are gastroliths, right? Like I find those fascinating also because I'm highly skeptical when people tell me that they are gastroliths because how the hell do you actually conclusively show that?
Acid etching.
Acid. Okay. Because I've had a number of times, I used to work in Utah, and people would find, rounded cobbles and like maybe some chert or something like that and be like, it's a gastrolith. And they'd be like, it obviously is because there's nothing else like it in the environment. And I was like, I don't think that that's actually a solid enough. And again, like, not everything in the rock record has to do with life. I know we would like it to, but I have to say that for my sedimentology peers who get annoyed with paleontologists interpreting everything as like a sign of life when sometimes it is not that at all. So, will you also explain what a gastrolith is and like more about that?
So a gastrolith is basically, it's typically a rock that is swallowed by an animal that does not intend to digest the rock, but is going to use it to help break up vegetation. So like chickens, for example, birds have gastroliths. I think alligators do too. Does that sound right to you?
I don't know.
We'll take it out if it's wrong. But birds definitely often have gastroliths. They pick smooth stones that they can swallow. I think they don't even always hold them in their stomach, but some of them hold them like further up in their digestive system, like in their crop. And they are essentially like, in some ways I'm kind of jealous because it's like being able to go swallow gravel for dentures. Like it's very, very simple ways of digesting their food. So dinosaurs, we think probably a lot of dinosaurs also had gastroliths. Gastroliths are going to be the most difficult ones to prove because they could just be rocks. And again, if they haven't been in there for very long, there's definitely no acid etching. And acid is only so potent. There are going to be some rocks. If a dinosaur swallowed a bunch of diamonds, I don't know that you would find acid etching on them.
Bougie dinosaur up in there.
Super bougie dinosaur tum-tum. So yeah, gastroliths, they're easiest to identify when you find them inside the body fossil of a dinosaur. Like
that makes sense. That makes sense. Right. Like these ichthyosaur coprolites too. It's like the association really helps. So it's like if you find it in the context of a sauropod, then that's more.
Yes. Yeah. So sometimes just the rock is a fossil, but also sometimes what you think is a trace fossil is just
a rock.
A rock. And I want to end on a story of a fossil that people thought was a footprint. So it's a fossil called Thinopus, and it's 3 fingers essentially. So it looks kind of like if you're holding up the peace sign but with your thumb out. So you only have 3 fingers, then put them all kind of pointing in the same direction. That's what Thinopus looks like. But the tips of the fingers are really skinny, like really, really skinny, pointy. And so it has been interpreted in like the last 10 years as maybe not being like one of the first footprints, but being a poop. It's a fish poop.
Oh, it's a fish poop.
Yeah.
It's a fish. Yeah. Well, they poop a lot, so you would think that
fish
some
do.
of that would.
That's a fish fact for you all. Lots of poop. Yeah, sometimes it's a footprint, sometimes it's not, sometimes it's a poop, sometimes it's not. And that is trace fossils for you.
Thank you for listening. If you like the podcast, be sure to rate and review us on your listening platform of choice. We really, really, really appreciate it.
If you'd like to hear more and support the show, you can follow us on Patreon for some exclusive bits or on our various social media platforms. You can follow Amy on Instagram at Mary Anning's Revenge.
And Megan on Instagram and TikTok as Geopedal Fabric, or both of us at Weird and Dead on Instagram and TikTok. This podcast is brought to you by the Geology Podcasting Network, produced by the Traveling Geologist, aka Chris Spencer. Our theme song is Unlock Me by Praz Canal.
You can follow them on Spotify, PrazKhanal.
Cover art was provided by Chris Spencer and the hosts.
Editing services were provided by Abby Jansen and Chris Spencer and a little bit of us as well. And this has been hosted and researched by us, Amy Atwater and Megan Weatherall. Thank you for listening. A very funny name for the title of this paper.
Enigmatic origin.
I think you could call any coprolite having an enigmatic origin unless it's found adjacent to the butthole.